Why these early galaxies shouldn't exist. What if astronomers discover galaxies that shouldn't exist? Galaxies so large and bright that according to decades of scientific models, there simply wasn't enough time to build them. These discoveries are real, they're recent, and they are forcing scientists to rethink how fast the universe learned to form structure. For decades, astronomers believed that they understood how galaxies form. After the Big Bang, the universe was hot, fast expanding, and nearly uniform. Matter needed time to cool, slow down, and collapse under gravity. According to these models, the first galaxy should have been small, faint, and inefficient at forming stars. Some of these early galaxies are already massive, dense, and forming stars at extreme rates. In some cases, they appear to be producing stars hundreds of times faster than Milky Way does today. That level of activity should require long periods of buildup, the time that the young universe simply did not have. This creates a timing problem. Galaxies grow through a slow process. Gas falls inward, stars ignite, explosions push material back out, and gravity pulls it in again. This cycle repeats over billions of years. Seeing large structured galaxies only a few hundred million years after the universe began is like finding a fully grown forest where only bare soil should exist. The James Webb Space Telescope made this mystery much harder to ignore. Its infrared vision allows astronomers to see galaxies that are both extremely distant and extremely ancient. When Webb observed these early regions of the universe, it found far more massive galaxies than previous theories predicted. At first, scientists assumed the measurements were misleading. Maybe these galaxies only appear massive because their stars are unusually bright. Maybe dust is distorting the light. Maybe the distances are being miscalculated. Researchers tested all of these possibilities, and while some estimates were reduced, many galaxies remained far too large for their age. Another issue is chemistry. Early galaxies should have been made almost entirely of hydrogen and helium, heavier elements, the ones that help a gas cool and collapse efficiently, were supposed to be rare. Without them, star formation should have been slow and difficult. Yet, these galaxies seem incredibly efficient, converting gas into stars at a speed that challenges current models. To explain this, scientists are now exploring deeper possibilities. One idea is that dark matter formed the dense structures much earlier than expected, creating powerful gravitational wells that allowed galaxies to assemble rapidly. Another possibility is that the first generations of stars were fundamentally different, much larger, shorter-lived, and far more energetic than stars today. There is also the possibility that galaxy formation itself is more flexible than we thought. The early universe may have been capable of organizing matter faster and more efficiently under extreme conditions. If that's true, then our models weren't wrong. They were incomplete. What makes this discovery so important is that it doesn't overturn physics. Instead, it exposes how much we still have to learn. The universe followed the rules, but not the simplified version we expected. Every time we look deeper into space, we are reminded that cosmic history is not a straight, predictable story. It is fast, complex, and full of surprises. And these early galaxies are proof that the universe learned how to build structure far sooner than we ever imagined. The universe isn't finished surprising us. What makes these discoveries so incredible is that they are real. They were not imagined, predicted, or expected. They were found by scientists who thought they already understood how space works. Every time we discover something that shouldn't exist, it forces science to grow. And somewhere out there, right now, something else exists that we haven't discovered yet. Something that will once again make scientists say, this shouldn't be possible.